Hi friends, today we will see another concept in fluid dynamics, that is the equation of continuity. The continuity equation is based on the principle of conservation of mass. And this law states that mass can neither be created nor destroyed. In this video, we will see the derivation for the equation of continuity. Let us assume a pipe or tube of varying cross-section. Now let us look at some examples of different cross-section. For an ideal condition, we assume that the fluid flowing through the tube is non-viscous and incompressible, undergoing a steady flow. For there might be an energy loss due to friction if the fluid was viscous in nature. Let the density of the fluid be ρ. The cross-sectional area of the tube at A and B be A1 and A2 respectively. And the velocity of the fluid flowing at A and B be V1 and V2 respectively. We know that volume is equal to length into breadth into height. Here, length into breadth is the area. So we can write volume as area into height, and let this be the equation 1. From the distance velocity prism, distance is equal to velocity into time, or velocity is equal to distance by time, and let this be our second equation. Now from equation 1 and 2, the volume of the liquid flowing per second is equal to the product of area and velocity. That is, V is equal to A into V. From this, the volume of liquid entering per second through A is equal to A1 into V1. Similarly, the volume of liquid leaving per second through B is equal to A2 into V2. Let us keep in mind that the fluid is incompressible and it is in a steady state as said before, and so the mass and the density remains unchanged. And according to the law of conservation of mass, the mass of fluid entering the tube per second through the section A equals the mass of fluid leaving the tube per second through the section B. That is, A1 into V1 into ρ1 is equal to A2 into V2 into ρ2. From the above third statement, the densities of the fluid are same. That is, ρ1 is equal to ρ2. And so, they get cancelled. A1 into V1 is equal to A2 into V2. Therefore, AV is equal to a constant. This is known as the equation of continuity. Consider you are holding a garden hose. Now compress at its end. Can you notice the difference in the velocity of the water leaving the tube? So from here we understand that as area decreases, the velocity increases, which means area is inversely proportional to velocity. Now friends, it's your turn. Apply the equation of continuity in the following given examples and do try to relate it wherever possible in your everyday life. Thank you.